everybody. I'm Josh Adams from Isotope 11.
And I'm Robby Clements from Isotope 11 as well.
And this is going to be awesome because we're going to talk about robots. All right, this talk has like two parts. The first one is just a brain dump, just good information about the library landscape, what's available for you to play with. And then after that, we're going to dig into sort of the story of building a project together.
All right, so let's dive into the survey so you guys can see what is out there. So what is a robot? Well, a robot is a force multiplier. It lets you take a simple action and cause a cascade of more complex decisions and actions.
Lame! Freaking robots. We know what robots are. They're awesome. This is why you came. No definitions.
So mass production of sensors for phones has made all of this really affordable, while the maker movement has made it approachable. And these are just a few great resources available, I think Make's probably the first among them, and we keep a bunch of these magazines around the office. They make great bathroom reading material. And so R2 is like Sinatra, but for robotics. It's definitely leading the pack right now. Serial port is an easy way to use serial devices, but it has some issues. Hybrid Group, though, they have a fork of serial port, and they have those issues worked out.
And Hybrid Group is actually really awesome. They're the guys that brought us R2, I believe, and a lot of the gems for playing with the toys.
Yeah. And so Rock Robotics, they're mostly C-based, but it's all wired together with Ruby. And Python is presently outpacing us in robots, but Ruby is the future.
Why is Ruby such a great choice, Robby?
Well, all the normal reasons. You have DSLs, metaprogramming, developer happiness, because you can have fun writing your robots and not just playing with them.
All right, so R2. R2 is really awesome, we mentioned that, and it provides a common interface for various devices. It's made really for controlling toys, which is really fun. It's an easy way to get started in this stuff. It gives you a really easy way to roll a web API interface for a robot or your system. It also happens to use the Ruby gem Celluloid, which is easily my favorite Ruby library. It allows you to do awesome concurrency stuff inside of Ruby.
All right, so where should you start? Well, don't start with a giant project because it's very easy to get bogged down with a small hardware problem like resistor values.
When should I learn Ohm's law?
Right, so you want to get some easy wins up front to help keep yourself motivated. I suggest you either buy a Sphero or a Parrot AR Drone, which we have both today. You just play around with them. So this is a Sphero, and it's basically just a ball with a motor inside of it. It's Bluetooth controlled via serial port, and it's a lot of fun, and it's really simple to play with. These are really good for someone who's learning how to program, and then you can see real-world results with the code that you're typing. It's good for kids and keeping them engaged in what they're learning. So there's also tons of like Kids Ruby R2 resources for the Sphero. So here we're using the Sphero library. You can see we just initialize our Sphero class, give it a speed and a direction, and it rolls. It's as simple as that. So I'm going to go ahead and show you guys this thing rolling.
And guys in the back, you're going to have a hard time seeing it, but
yeah, because it is on the floor and it's small. There it goes.
That's not it.
Should he go into the stage? Yeah, he's good. There you go. Okay, cool.
All right, so this is version 2 of the Sphero. We had version 1 of the Sphero, and it seemed to work better. I think they changed the protocol, and maybe the gem doesn't. I don't know. There's something finicky, because right now it's still trying to go, even though we told it to stop.
Right, so we told it to stop, so now
anyway, so we have another script that kills it.
Yeah. All right, there we go. Oh. Sweet. All right, so here's an example of using R2 to control an armada of Spheros. So what's cool here is you can see how multitasking works with this evented architecture. And what we're doing is we're taking 5 different ports, and then we're initializing them as individual Sphero robots, and then passing them to that work block, and that allows them to all roll at the same time concurrently.
Okay, so the other easy toy to play with is the Parrot AR Drone. He's right there, you can see him. This guy creates his own Wi-Fi access point. You can connect to him, and then you just send him UDP packets to control him. He's also got a couple of video cameras, one on the front and one on the bottom. One of these guys costs you $150 refurbished, and you can get a new one for around $250. Jim Ryrick wrote this gem called Argus to let you control it via Ruby, and R2 supports it as well via a wraparound Argus. So you just can make a new drone instance, start it, take off. This is the script we're running, obviously. You can take off, hover, tell them to turn, tell them to turn, tell them to land. It's really, really easy DSL. And this is sort of just why Ruby's so awesome. So Robby is going to go ahead and show you.
Crash.
Sweet.
That went way better than expected.
So we're 2 hardware demos in now with no malfunctions, so pretty happy about this. All right, so now you've got your easy wins. You played with 2 toys. You're still interested. We're like 6 minutes into a talk, and we've controlled 2 devices, so that's pretty cool. So what do you do like if you want to level up a little bit?
All right, so microcontrollers are essentially tiny computers. So what makes them so special is that they are on a single board, and they have I/O, input and output, never a miscommunication.
All right, so the Arduino showed up right around the same time that Make Magazine did, and they had a huge impact on hobbyists, although people that were doing this kind of thing beforehand, they'll hate you for saying that. Still, it's only a 16 megahertz device, has no storage, has no networking, had to be programmed in C. Now we have a whole range of options. There's the BeagleBone Black, there's the PC Arduino. The PC Arduino offers a 1 gigahertz chip, a gig of RAM, a Mali 400 GPU, and an Arduino-compatible pinout, so you can take advantage of the existing shields in the Arduino infrastructure. And if you're going to grab the PC Arduino, by the way, you want to buy the Arduino standoff board. It's like $7 because it takes the 3.3 volt signals out from the PC Arduino and pumps them up to 5.5 volts so that the existing shields will work. Anyway, those are both way more expensive and power hungry than the almighty Raspberry Pi. So with the Raspberry Pi, you get 700 megahertz, you get 512 megs of RAM, and you get networking, all for $35 on a single board, as well as lots of GPIO to hook into. It just really hits a sweet spot.
So the Raspberry Pi has several ports to play with as well. You have RCA video, audio, USB, LAN, HDMI, has LEDs on it. But the main reason that we use the Pi is the GPIO, those pins, or else it's just a really crappy computer. Setup's really easy. DD takes about 30 minutes. Other than that, you're running in under 15 minutes. But now they usually ship them with the SD card already loaded with Raspberry and Linux. So as soon as you open it out of the box, it's ready to go. Getting Ruby running on the Pi is even easier. I use RVM, which I think when I did the compile time could take a few hours, but now I think they have binaries, but I could be wrong. And Ruby 193 seems to be the way to go, but I expect that that's going to change pretty soon. So there's a few things to take into consideration when you use the Raspberry Pi. You have to be really careful with it and protect it. It needs buffering. So use transistors or a ULN 2003. And you have limited hardware pulse width modulation out of the box, but we're going to show you how to get around that in a little bit later. And you're also going to need at least a 1 amp power supply if you want to attach more gizmos to it, such as a keyboard, a mouse, Wi-Fi, Bluetooth adapter, webcam, fidget sensors like a compass, gyroscope, or a accelerometer. Then you're going to need a multi-port USB hub. Another accessory that's pretty necessary is the Pi Cobbler. It's a ribbon cable that attaches your GPIO pins to a breadboard, and it makes connecting off your pins much easier. And there's an $11 Serago USB Wi-Fi Bluetooth adapter, which we are going to be using today, and it works great for basic I/O and it's low power. Cases will help you keep it from shorting out. I didn't put a case on my first one, and now I have my second one. So you can also put heat sinks on it if you want to overclock it a bit. And Class 10 SD cards are the way to go. They're a lot faster for DD and UX. And Josh.
All right, so there's this gem called PiPiper that's the easiest way to get started with the Raspberry Pi. There's its GitHub repo. You can just go get it. It's obviously on Ruby gems. It gives you event-driven Raspberry Pi GPIO programming. So this is sort of just a real quick demo of how to use it. So you just require it, include it. It gives you a nice DSL. So you can say, for instance, watch pin 23. When it changes, run this block. Inside the block, you're going to have last value and value available to you. Or you can say, like, after pin 23 goes high, run this block. And then at the end of your script, you're going to say pipiper.wait, and that just blocks the process so that the eventing can run. You can also just use it for basic output. So make a new pin on pin 17 here. So turn the pin on, sleep for a second, turn the pin off. So if you take a LED, hook a resistor to it of the appropriate type, plug one end of it into pin 17, plug the other end into ground on the Raspberry Pi, this 4 lines of code will blink an LED in Ruby. So pretty great.
So there's lots of ways to control hardware as well. Serial ports, you just write to like you're appending to a text file. You can use USB, Bluetooth, GPIO.
DRB is my favorite way to do this. It's Ruby's default way of doing remote method invocation if you haven't played with it. It stands for distributed Ruby. It's really fantastic for just simple robots. And this begins the second part. So we're going to go through building something really neat. It's just a process I went through when I first started playing with RaspberryPi and Ruby. That's it. All right.
So we've got some easy wins with our toys earlier. We took a microcontroller and we made an LED blink. So what are our next steps? So going forward, we're going to have a lot of quick code. Our goal here is not to provide any sort of code examples. We're going to just try and demystify everything that's going on so there's no magic here.
Okay, so the first thing we did after we got like an LED blinking is we made it Twitter powered because social web or something, I don't know. So it's all Ruby and that's the whole point of this. I've done a lot of stuff in Arduino and doing stuff with Ruby just feels better. It's what I do all the time. So here's a really basic class you can use to search Twitter for a phrase. And then we wrapped it in this thing we called the toggle handler. So we made a new pin on pin 15. We used our search as tweets class. Every time, basically every second, it returned all the tweets at the top that had isotope LED in them, which is a Twitter account we made just for this purpose. If it was a new tweet that we hadn't seen before, we would either toggle the pin on or off depending on the content of the tweet. So if the tweet contained the word on, we would toggle it on. Otherwise, we turned it off. And that was kind of cool, but like, you can't really control a robot that way, right? So how about more direct control? So here is like my favorite part of what we ended up settling on. So we used DRB to connect JRuby on Android and MRI on the Raspberry Pi, which is really freaking cool. I don't know if anybody's ever written like their own custom protocol over serial. Not my favorite thing to do. So if you just use DRB, then you get lots and lots of stuff for free. Anyway, so this is just like the basic pickaxe example of using a DRB object. The object we're exposing is a toggler. He looks very similar to the other code you saw, right? He's a Pi Piper pin on pin 15. And then anytime you call the toggle method, he toggles it on or off, right? Very, very basic Ruby. And then we front him via a DRB service, and that's it. All right, so I know everybody came to this conference looking for Java, and we aim to deliver. So don't worry, you're going to get some Java code in this talk. It's not horrible. Okay, so the interface we're building, it is literally a button, a single button. It's the most basic interface you could build, right? So there you have it. Toggle that LED boy. Okay, this is the Java code for the main Android app. It's not terribly scary, but it has a whole lot of things that I learned along the way about JRuby. This is like 4 or 5 days of like beating my head against the wall, so I thought it'd be useful to share it. First off, you want to use the JRuby jars from the Rubato project if you do this. They've solved a lot of problems that JRuby on the Android has. Secondly, you need to set the JRuby bytecode version to 1.5 or 1.6, or else JRuby will explode. Thirdly, you have to actually load the standard lib into the load path, or else you spend 3 days crying trying to figure out why you can't even make a float. Yeah. All right. We also have to run an asynchronous task because you're not allowed to do network on the main thread. And you need your Android app to request the internet permission, or else you can't DRB. Finally, completely normal stuff here. We're going to cat some Ruby strings together to make a tiny DRB client and hook into a hard-coded URL. This is obviously production quality. Okay, and how does it work?
So we end up with something like this. So that's an Android app, and it's running on my phone here. And when I press the button, the LED toggles. So that's because Ruby.
That's a Ruby method
That's a
call.
freaking
Nice.
Ruby method call that I'm throwing over the network. Come on, that's amazing.
Yeah.
Yeah.
All right, so you made an LED blink with Android. What's the obvious next step? How about an RGB LED, right? So let's make that happen. Okay, so you want to have an RGB LED, a similar Android app, but we're going to control it via a color picker this time. So you change the color on the Android device, the color of the RGB LED changes in real time, cool stuff. Okay, there's a problem with this. An RGB LED requires analog levels, but we only have digital levels with Pi Piper. So we can't really use Pi Piper to solve this problem, although it's really cool for lots of other stuff. So pulse width modulation is the solution to it. I don't know if you're familiar with it, but basically you can use PWM to simulate analog levels. All that's really happening is you're switching a pin on and off at a certain speed. So for instance, if an output is switched on 10% of the time and it's evenly distributed, then it makes an LED think it's been sent a 10% max output signal. Later on, we'll use them for some logic level stuff, but for now, we're just using it to fake analog. All right, so the problem with that is the Raspberry Pi only has one PWM pin. You need 3 to do an RGB LED. So there's this user level or user lane driver called Pi Blaster that you can get online right there. It'll basically give you 8 PWM pins. It hooks into, low level, it hooks into the interrupt for the main PWM pin, splits it by 8, and then gives you 8 PWM pins that are pretty good. I mean, they're plenty fast enough. This is 700 megahertz is plenty fast to do software PWM. That's kind of like this nice shift between this and, say, an Arduino. Anyway, so here's how you can use Pi Blaster. Everything is just a file, and you just write commands to it. It's freaking Unix. So to turn off pin 1, you echo 1 equals 0 to the device. To turn on pin 1, you echo 1 equals 1 to the device. And to set pin 1 to 20%, you echo 1 equals 0.2. I mean, this is not hard stuff. All right, so I still don't want to write it, so of course we encapsulate it. So here's a very basic class representing an RGB LED. I'm just showing the red channel code here. You can probably figure out what the green and the blue look like. So you have a getter, you have a setter. I've encapsulated sort of the echoing of the appropriate stuff out to the device. And then every time you call Pi Blast, it calls the command for each of the channels. Really, really basic, except for it's like 200 lines long. If we'd used any metaprogramming at all, this would have been way smaller, obviously. But we promise you quick and dirty code, and again, we deliver. Anyway, so this is really good, and this gives you exactly what you need. Except that, like, I was wrong when I wrote it. And most RGB LEDs expect the common leg to be high, and the channel-specific legs to be like a modulated ground, and our code assumed the opposite, but it's freaking Ruby. So Ruby's awesome, and when I ran into this when I was testing it, it took like 3 seconds to fix it. I had to switch 2 wires, and then I had to write this class. So, yeah. There we go. And if you can't read that, that says super. Anyway, so object-oriented programming is awesome. This is one of the many benefits of using this instead of an Arduino. So let's go ahead and see what the Android interface for this project is going to look like. So this is a really basic color picker. There's nothing fancy going on. This is just some widget I found online. And as you change the slider, we want the LED to update in real time. Okay, so there's some more Java code, and I'll just let you guys read that. Just kidding. All right, so last time we ran code every time you hit a button. Now we have a slider. So at first I was like, cool, I'll like hook into an event handler, and every time I get a change event, I'll update it, right? But it turns out that DRB gets laggy, or it can't handle 200 messages a second. Like, so if you respond to every change event and you just drag it really fast, it gets behind. So there's a solution for this. Made a timer task. Basically, 20 times a second, I sample the user interface, and then I send a message over DRB that encapsulates the whole of the user interface. So one method call the entire UI. So if you're going to go this route, sorry. I found out later that this is exactly what RC controllers do. They just sample the interface 20 times a second, and it's the same number even, which made me really happy. Like, it's serendipitous that I just happened upon the same thing. Anyway, so that's basically all the code to do this Android thing, very similar to the last thing we saw. And how well does it work?
As we move things around, we update a freaking RGB LED. All right, that's awesome. That's all.
All right, so pretty darn well.
All right, so we have we've got pulse width modulation control of a Ruby process from Android now. What's next? Well, this here is the RAD2, and you can get other toys just like this that have a tank steering base at thrift stores for about $2. And what was once loved by a child only to be thrown away can be yours to love again. Only this time it's going to be way more awesome. So we're going to finish up by building, we're going to use the base of the RAD2 and build a RC tank steering thingy.
All right, so let's get started. Real speed construction here. You're going to take a Sabertooth 2x12 RC motor controller at 65 bucks. You add a RaspberryPi, that's like 35 bucks. You add a 12-volt battery, they're 20, or you find one somewhere. Get a Sphero Wi-Fi Bluetooth stick for like 11 bucks, and then you mutilate a USB micro cable. So there's 130 bucks, and you put it all together and wave your hands around, and you end up with this. And so that's kind of cool looking, right? Oh, 3D printed case too. Anyway, so this is what we have on the floor right there. And anyway, real quick before I get to the next slides, I wanted to kind of go over the PWM and the Sabertooth. A lot of this is just to make you comfortable with the sort of thing that ends up happening. Okay, so to control the Sabertooth, you send a PWM signal per motor, so 2 PWM signals. 2,000 microsecond pulse width is all the way forward, 1,000 microsecond pulse width is all the way backward, and 1,500 is idle. Okay. Then on the Android interface, we really want like 2 sliders, one for each side. It goes from -1 to +1. They're very bog standard tank steering controls. So you end up with more code like this. This is just some code that's going to map the values to the appropriate PWM. That's like almost the only thing that's different from anything you've seen before. This bit looks familiar. This is just the DRB object. And some Java code. It's very familiar too. No one needs to notice that I'm using a global for flow control. And this is, again, production quality. All right, so I figured I'd show a demo, and we'll see how well it goes. All right, so if it doesn't work, then Robby will talk.
All right, so while he's getting that to work, I just want to mention last night, we had to repair this thing. Well, it actually was repaired right before we came, but when they hooked it up, the motors were hooked up backwards. And in a hotel, we had no screwdriver, we had nothing. So instead of rewiring it, we just changed it in the code, programming. So
Okay.
it's, one of them's backwards, but it's going forward.
Sorry, the interface is a little bit fiddly.
There we go.
Yeah. Anyway, so Ruby and a tank. Anyway, thanks for being really attentive during our talk. As a really generous thanks for attending the talk, Isotope 11 has provided free iPads under everybody's seats. Nobody. Okay, fine. We didn't do that, obviously.
All right. Again, though, thanks for coming. Follow us on Twitter. You can see all the antics that we do, like try and blow up LiPo batteries and burn our hands. And Josh actually does Elixir Sips, which is learning Elixir, following him learning it. And we're on IRC, Freenode, Isotope 11. Check out our blog at isotope11.com.
And we're going to leave you with this.
Face off! Oh, sweet! AR Drone been taken out by the glow ball. No match for the Rasp tank. Get the AR Drone! The AR Drone needs to take off. There we go. Double kill!
The only way to take out the AR Drone is to take out its master.
Get him! Tank is awesome. Headshot.
Yep, that's it. Get that.